Good morning all. Now I am going to explain about formation of PN junction diode. Okay, PN junction diode is formed by combining P-type material and N-type material. Okay, first we will discuss about P-type material and N-type material. Now see here, this is a P-type material. Okay, in P-type material, holes are the majority charge carriers. Okay, this small circles represents holes. Okay, next, electrons are the minority charge carriers. Okay, those minority charge carriers are represented by dot. Okay, similarly here negative ions represents, this negative ions represents third group elements or are acceptor atoms. Okay, that means in case of p-type material, holes are the majority charge carriers and electrons are the minority charge carriers. Okay, and in this p-type material, this negative ions is represented by acceptor atoms or third group element. Okay, that is about p-type material. Okay, next coming to n-type material. In n-type material, electrons are the majority charge carriers. See here, this dot represents electrons. Okay, holes are the minority charge carriers. 3 holes right here. Okay, next this positive ions represents donor atoms or are fifth group elements. Okay, that is about n-type material. Okay, that means p-type material, electrons are minority charge carriers and holes are majority charge carriers. In case of n-type material, electrons are majority charge carriers and holes are minority charge carriers. Okay, now by combining this p-type material and n-type material, PN junction diode is formed. Okay, this is p-type material and n-type material. By combining p-type material and n-type material, PN junction diode is formed. Okay, when we combine these two material, diffusion process takes place. Diffusion is a natural process. Okay, the movement of charged carriers, okay, will move from higher concentration to lower concentration. Okay, see here, in case of p-type, holes are majority charge carriers, right? Okay, that means these charge carriers will move from p-type to n-type. Similarly, in case of n-type, electrons are the majority charge carriers, right? That means these electrons will move from n-type to p-type. Okay, this is nothing but a diffusion process. Diffusion is a natural process, okay, through which the charge higher concentrated charged particles will move from higher concentration to lower concentration. Okay, that is nothing but diffusion process. Now see here, diffusion is a natural process through which charge carriers will flow from higher concentration to lower concentration. Okay, already we know that in case of p-type material, holes are majority charge carriers, right? Then these holes will move from p-type to n-type and recombine with the electrons and create negative ions near the p-side junction. Now see here, this is a junction, right, which separate p-type material and n-type material, right? Now see here, this hole is try to recombine. That means due to diffusion process, hole will move from p-type material to n-type. Again, this hole also will move from p to n. This hole also will move from p to n and recombine with the free electron available in the n-type material, right? When this hole will move from p side to n side, see here, negative ion, only negative ions present, right? Negative ions are created near the junction. Okay, similarly, due to diffusion process, when this electron will move from n side to p side, okay, and recombine with the hole, okay, then it will create a positive ion near the junction, right? Okay, that means see here, due to diffusion process only, okay, negative ions and positive ions are created near the junction. Okay, that is nothing but in thermal equilibrium, the region near the junction, there exists a wall of negative immobile ions. Negative immobile ions is nothing but there is no movement of ions. Okay, immobile ions on p side and positive immobile ions on n side, right? This is p side and this is n side, right? Okay, that means negative immobile ions and positive immobile ions will be created, right? Okay, the region which is having the immobile charged carriers is known as depletion region or depletion layer. Okay, next, barrier potential. Okay, now see here from this figure, near the junction, right, near the junction, one side is negative charge, right, another side is positive charge. Okay, when negative charge and positive charge is present, according to Coulomb's law, there exists a force between two opposite charges, right? Okay, then this force will produce as an electric field, right? Okay, the direction of electric field is from positive terminal to negative terminal. Okay, that is about the direction. Next, the because of the opposite charges, okay, there, because of this opposite charges near the junction, which will create a potential difference, right? Negative positive is nothing but it will create a potential difference. Okay, that potential difference is known as barrier potential. Okay, that is about formation of depletion layer or region and barrier potential. Okay, remaining we will see in next class. Thank you all.